In this tutorial, we are going to teach you how to make the 3D hexa mesh for the NACA 0012 3D wing with sharp tailing edge. The sharp tailing edge cases are more difficult to mesh with the hexa as compared to the square or the blunt or truncated trailing edge. So to be clear, I am talking about this region which is difficult to mesh in the far field and as well as in the block which is on the top of this wing, especially this area. That's why this is the blocking approach is going to be different as compared to the blocking approach for the aerofoil or the 3D wing with the square or the round trailing edge. Most importantly, in this 3D case, we have the also a region or the block which is above the this blade tip or aerofoil tip or wing tip that also has to be meshed. And you must know difference between the infinite wing 3D simulation, especially used for the alias type of the programs, in which the wing extends to the top and the bottom boundary. So this boundary has to be here or this wing has to be here. But in this case we have this region which is also needs to be meshed. So let's start with creating the 3D blocking. But first of all I will show you the regions which are here. It's the inlet, it's the outlet, side 1 on the top. We'll define the symmetry condition also for this wall or the slip condition. So side 2, symmetry and the top. These all four conditions are going to be defined as the slip wall or the symmetry conditions. You can change the colors to some random good colors and just save the file to be sure that the everything latest is saved into the ICM CFD project. Now go to the blocking and use the option which is the create block and create a 3D block here. Do not change any option here, just use the default settings. Okay, just click on then on the apply. So we are with now with the 3D block, which can be visible if you turn off the geometry, points, curves and surfaces. Just turn them on again. You can turn off the surfaces for a time being. Now you need to associate the outer edges to the outer curves and the outer vertices to the outer points. This can be done in a one click with the auto associate. This will save you a lot of clicks on the mouse. Apply. So this has done the job of associating these 12 edges to the 12 curves, but you can see the vertices are still green. This means that they are not associated to the corresponding points, otherwise they would have the red color. So you have to associate the edge vertices manually to the corresponding points by choosing the option which is the associate vertex to the point, which is default option. Do this one for the all 8 vertices at the outer boundary. No need to use the middle mouse button, just click on the vertex by the left mouse button, then again click on the same location. This will select the corresponding point. So this is done. Now you can display the curves. Go to the views and select the front option. This will align your model in the z-axis. Now you have to make the one split a bit ahead of the this wing, not exactly on the wing points, which is done for the wings are aerofoil with the round or the square tailing edge, so it should be somehow upstream of this geometry. Now it has to be decided by yourself where you want to have the O-grid location. So done. Now you need two more splits, so which has to be up and down. You should calculate there should be uh, there should be symmetry between this split, that the half distance should be upstream, half distance should be on the top, and half distance should be on the bottom side. So this will maintain the symmetry and also the mesh quality. So this can be done in the various ways. For example, if you undo this one and just let me create a few points, let's say at the point 4 location on this curve and the point 6. This will make sure that we have the symmetry in the geometry, in the blocking also, because the aerofoil or wing is midway between uh, these boundaries on the top and bottom. So by making the 40% and 60% location, 20% area or length is going to be used for the making the splits for this block. So you have to choose option that is the by prescribed point, the method. So this will ensure the symmetry in the model. Once it's done, now you can go and create the O-grid. I will use the simplest possible approach, but I can go for the even some difficult approach. But right now I'm not going to make any blocking approach which is difficult for you to follow. So we have selected the block which is behind this arrow file. Now you have to select the three faces, 1, 2, and 3. These are to be decided in a way that where the O-grid should pass. So the top and bottom should be selected because we don't want to have the O-grid which is pointing upwards, which will basically has a no benefit and it will not improve any quality. So this is to they have to be selected, and the face at the outlet domain at outer boundary is selected because we want the C grid. If you want the full O grid, then don't need to select this face. If you want the half O grid or the so-called C grid, you have to select this vertex or this face over here, and then click on apply. Okay, next thing which need to be done is to split the block at the trailing edge of the geometry. So again we use the prescribed point option. Okay, we can align the points in a line by using this option. Or we can use this option which basically directly enforce the coordinate on the location on the selected vertices. So we got the location where we want to set these vertices from these four vertices. Any vertex can do the trick, and the vertices which are need to be moved are these one, two here, two here, two here, and two here. So total 8. So you have to modify the X already selected, then you have to select the vertices to set. So you can select them in the group by dragging the mouse on in a square on these vertices to select them all in a one go. They can be 2, 3, 4 or 10 or 20. They will be selected in a one go. Click on apply. So now they are in the one line. Okay, I think we have made some mistakes, so just let me go back. Okay, again select the same faces, these three faces. Now this is all right. I think last time maybe we have missed the up and down faces, and then repeat the same procedure. And the vertex movement. Now you have to collapse the block at the trailing edge. So select this vertex which is just on the trailing edge and the block which is behind the trailing edge. This will collapse the block which is selected, and if you select more blocks they all will be collapsed depending on the edge selection of the geometry. So the block which is beyond this one is collapsed. Same same command can be used if you use the merge vertices option and then merge to average, but you have to apply the four operations. And previously we have just done one operation and that's the same result was achieved. So you have the option that you can use any option which is easy to you, but in my approach this option is much easier because maybe we have the maybe 4, 5, 6 blocks and which will multiply the number of vertices to be collapsed. So it's not a good idea to select the vertices one by one. So now it's done. You can associate the this vertex on the trailing edge. Okay, after doing that, I would suggest you to group the curves in a one curve, and the method you should choose is the all tangential. So any curve which is tangential to the second curve, they will be all will be grouped. So the example is would be this one, these two curves here, 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 and also on the trailing edge. They will be grouped automatically. Okay, so just click on apply. No need to select any curve, and you can see that they have changed the color to the single color, which means that now they are all grouped in a single curve. This will help you when you associate the edges to the curve. So you have to select only one curve instead of selecting the 4 to 5 curves in a one go. Now associate these edges to the bottom curve. You can use the index control to have the edges which are only to be used for this process, which can make it easy to visualize the things on the computer screen. Okay, now move these vertices to the corresponding vertex. But after we have moved this vertex to the points, we'll use the option that is associate point to the curve, because this will give us option, and also this will uh, make the meshing or the blocking approach easy to follow the geometry. Otherwise, it will over constrain the your mesh. Okay, now you can reset the blocking here. Now we need one more split on the top side of the wing. So again, go to the split block and use the same option, that is the prescribe point, and then select the corners again to just show the edges which we want to work on. Again, associate the edges here, and then associate the corresponding vertices to the points, and then again we'll change the association to the curves when we have the some well defined curve edge locations. So again, change the option to the curve and select two vertices and convert them to the curve. Okay, now you have to align the block on the top side. So use this option, this edge and this vertex, apply. So we are almost done here. Now I have to make few splits here, like a split here, one here, and one almost in the middle of the geometry. And use the option which is here, that is snap vertices. This will move them to the corresponding curves. Okay. Okay, just also change the select the blocks which are just inside the this wing. So you have to play with the index control. Okay, this is working. So we are just have the blocks which are inside the wing. Now you can use the same vertices command. This will align them perfectly. Now again reset the blocking here. Now play with the index control for the O grid just to display the blocks here. And now use the option, that is align vertices, and choose any edge and the top vertex on the tip side to align the blocks on the in the gap in the inside the this aerofoil. This is done. Now you can reset the blocking. Okay, now we have to go and create the Y block. There is to address this triangular block. You can go for the quarter O grid, but that has to be this has to be done in the very starting. So now we are only left with this option of creating the quarter O grid with using the this Y block command. Now we have to create the O grid inside these blocks. Sometimes people ask me that why I change the block inside the wing which is not used for the CFD analysis through the solid, because this will be useful in many ways. For example, if you create the Y grid and just on the top of the tip, this will give you many problems. Secondly, when you create the O grid which is on the top side of the wing block, if you create the also O grid same grid inside the wing, this will be useful in controlling your blocking in a very easy manner. And secondly, you can turn off the solid block. This mesh won't be exported to the Fluent or the CFX. So just you have to unselect the solid block from here. This will make the mesh go away from the model. So just as very simple and straightforward. So you have to again go for the O-grid generation, and this time for these blocks. Now select the faces on the top and the bottom side of these blocks. Do not select the block which we have converted to the Y block. And now apply. You can also change the block inside this wing to the solid. Okay, so once the material is changed, this will be useful when you are going to do the heat transfer analysis, because we need the mesh also inside the wing, or we are going for the some fluid solid interaction. We also need the mesh inside the wing, but that's a different story. So we are not going to explain this thing here. You can watch our other tutorials. So just hide the solid from here, and the edges on this boundary they will turn into the black color. This shows that now they are associated to the corresponding surface. Now you can select the size of the mesh on the different edges. Let's say on the aerofoil surface or wing surface 50 points, here 30 points. Here I'm not going to optimize the spacing or the mesh edge mesh parameters. Here 8 points. I'm just making the some decent mesh on the wing to show you the quality of the mesh after. So make it 30, 40, these parameters by yourself. Okay, now let's check the quality of the mesh. The angle is 19.71, which is higher than the required value, and the quality is 0.539, which can be increased. First of all, you have to see where the problem is. Okay, this is a problem area. Now you can mesh the edges here, and also you can increase the number of nodes here. Okay, let me increase the number of nodes here and decrease the size here. You can also move these vertices inside by using this option. This will also increase the quality. Okay, now you can work also on these portion of the blocking where we have the problem, but the minimum quality required is 0.3 and the minimum angle required is the 18 degrees, or even you can go for the angle of 9 degrees. You won't have any problem with any CFD solver. So these are the good matrices. Even I can say it's a very good matrices, and we are going to stop here. Thank you for watching this tutorial. And if you want to have any queries, you can write us at the given email ID in the description. Thank you.